Hey everyone, welcome back to my channel. I'm German and today we dive into Docker, the game changer in software development that's like Uber in app deployment. Imagine trying to run your code on different machines, but versions clash, dependencies break and everything falls apart. Docker fixed that by packaging everything into lightweight container. Think of them as your lunchbox with food inside, but instead of a food is your app. If you're a complete beginner and only start your career path, or just curious in dev tools, this video is for you. We'll cover installation, key components, and hands-on example to get you running your first container. By the end, you will be Docker ready. Hit that subscribe button, hit that like button, and let's get started. First off, what is Docker? It's an open source platform for building, shipping and running applications in the containers. Unlike heavy virtual machines, Docker containers are lightweight, fast and share your host OC kernel, saving resources and ensuring it works everywhere. This is huge for developers, data teams and anyone scaling apps. Before we install, let's break down Docker's key component. Understanding this will make everything clear. Docker engine. The heart of a Docker is the core software that manages containers. Think of it as the engine in the car. It powers everything without you needing to know the mechanism. Docker Daemon. This runs in the background, handling the heavy lifting like building images, running containers and managing networks. It's like a silent butler managing your app household. Docker Client. The command line tool used to interact with Daemon. You type command like docker run and it tells the daemon what to do, super user-friendly for beginners. Images. Ready-only templates for your apps, like blueprints or recipes. They are built from a Dockerfile and include your code, libraries and OS basics. You pull them from Docker Hub or create your own. Containers. Running instances of images, like a baked cake from a recipe. They are isolated but efficient, and you can start, stop or delete them easily. Volumes. For persistent data storage. Containers are ephemeral. They don't save data by default, so values act like external hard drives, keeping your database or files safe even if your containers restarts. Networks. Allow containers to communicate. Docker creates a virtual network so your app in one container can talk to a database in another, just like device on Wi-Fi. These components work together seamlessly. Daemon orchestrates, client commands, and the rest handle the details. Now let's install it. First step, check your system. Docker works on Windows, macOS or Linux. You need a 64-bit OS, at least 4 gigs of RAM, and virtualized enabled. Installation. Head to the docker.com and download Docker Desktop for Windows or macOS. It's an all-in-one package with the engine, CLI and more. For Linux like Ubuntu, use the terminal for clean setup. All the commands you need for setup I will post in the GitHub repository. Step number 3. Start and verify. Launch Docker Desktop. In your terminal, run docker -- version. You should see something like this. Docker version and the version of your Docker. To avoid typing sudo every time on Linux, use this command. For Windows or Mac OS, run the installer, follow the prompts and enable VSL2 Windows subsystem for Linux. In settings for better performance, it is a key component that lets Docker run Linux containers natively. Step 4. Basic setup tweaks. In Docker Desktop settings, adjust CPU, memory allocation under resources, great for resource-heavy tasks like data processing. Also explore the dashboard to monitor running containers visually. Now let's put those components into action with a real example. Pull a simple image from a Docker Hub. This download the image. Notice how the clients talk to the daemon to fetch it. Run a container. Boom, you see hello from Docker, the container ran, printed the message and stopped. Easy, right? Let's level up. Run an Nginx web server container using networks and ports. -D, detach it, runs in the background via Daemon. -P and ports maps host port 8080 to container port 80. -name gives it a friendly name. Now with our server IP, we can open port 8080 in our browser and voila, Nginx welcome page. This shows how containers isolate apps while connecting to the outside world. To manage, list the containers with a Docker PS. Stop with the Docker stop Nginx and remove with the Docker remove Nginx. Quick advanced tip for data persistence and a volume. With this command. This mounts a host directory to the container, saving files via volumes. Now let's try example for developers. Create a Dockerfile for Python app. It will be a basic app just to show you how it works. Use your preferable text editor to write a Dockerfile. And save it. And let's write some small app.py. We receive output from execution of our app. See, you've built an image and spun up a container. Core Docker workflow. There you have it. You set up the Docker, explored key components, and launch your first containers. This is the foundation for everything, from web scraping like my previous videos to full-scale data pipelines. If this helps, give this video a thumbs up and subscribe for more Docker, N8N and IT career tips. Drop a comment what's your first Docker project and see you in the next one.